Hello everyone, welcome to this video. In this session, we are going to learn about recursion. We will understand what recursion is, how it works internally using the concept of stack, and we will also see real life world analogy to make it easier to understand. Then after that, we will go through some coding examples like GCD, Fibonacci series, etc. So first, what is recursion? What is recursion? Recursion simply means a function calling itself, we can say. Recursion means function calling itself. Instead of solving a full problem directly, we solve a smaller version of the same problem by calling the function again and again. Okay, uh, let me show you one example. Like if I write void message print f hello backslash and I will call this function message. Okay. Now, if I run this function, okay, it will keep printing hello and again. You can see here, this function, this is recursive call. This will call this function. It will print hello. Again, it will call. It will print hello. Again, it will call. It will print hello. So this will keep printing. Okay, and finally, this program will crash. Why? Because we never told it when to stop. Okay. So here base case will come. Okay, base case will come. Okay, now let me fix this code by adding a base case. Okay, okay, I will write here same code. I will write void message int n. I will write base case here first. If n is equal to 0, return, and now print if hello. Okay, now I will call this message. I will write here n minus 1 with it will approach to 0. Okay. Now if I call message 3, let's say n is 3. Okay, n is 3 here in 10 3. Now what will happen? It will print hello. It will print hello. See, n is not 0. So it will print hello. Then n minus 1. So 2. Again it will call here message 2. Again it will print hello. Now message 2 minus 1. So here 2, it is 2 now. Now message 2 minus 1, that is 1. Now again it will call. Again it will print hello. Now again n minus 1. That is 0. Now n is 0. So it will return. So it will print this. Okay. This is the correct way of writing recursive function. Always define base case. Always define base case. Okay. Now let's go a bit deeper. Uh, I will explain you how recursion actually works internally. Okay. How recursion works internally. I will explain you this. Recursion works with the help of call stack. Call stack. Every time we call a function, it is added to the stack. When the base case is reached, the function start returning and the stack is cleared step by step. Okay. Now let me show you one example. Again, I will write same code. What it was, void print int n. If n is equal to 0, return and print f percentile d backslash n. Okay. And n minus 1. Okay. Okay. Correct. Yes, correct. Now if I call print 3. Okay. Print 3. If I call print 3, what will happen? Internally, what will happen? I will show you. Okay, see, this is stack. Okay, this is stack. One, two, three, like that. I will draw. Okay, now this is stack. First print 3. Okay, print 3. Okay, print 3 is called. So it will go inside stack. Okay, it will go inside stack. Here it is, print 3. Now n minus 1. N minus 1. Again it will go. Print 2 will go. Now print 1. Now base case found. Okay, so return. Now as we know, what is stack? A stack follows LIFO, last in, first out. So first print 1 will be pop out. Print 1 will be pop out. I will erase this. Print 1 will be pop out. Now in second, after that, this print 2 will be pop out. After that, I will erase this first. After that, you can see this print 3 will be pop out. Okay. So remember, recursive call go deep down into the stack. Okay, you can see here go down deep into the stack, and once the base case hit, everything start returning one by one. Okay, now I will explain you recursion using real life analogy. Okay, I will explain you using real life analogy. Real life analogy to understand this recursion. Okay, okay. Think about a stack of plate in your kitchen. Okay, you put one plate on top of another. Okay, this is first plate, this is second one, this is third one, this is fourth one, like that. Okay, you can't pull the okay, if I want plate, okay, we can't pull it from down. Okay, we can't pull it from down. What we will do, see here. Oh my god, why it is not working? Why it is not working? Okay, now it is working. See, first plate, then second, then third, then fourth. Okay, like this. So this is how stack work, this is how recursion work. And one thing I will tell you, actually every code of recursion we can write using stack as well, because internally recursion is working with the help of call stack, as I told you earlier. Okay, um, where actually we use recursion, we use it, where okay, first is um, binary tree traversal. Binary tree traversal, already we know what it is. Binary tree traversal, what pre-order, then in order, post order. Okay, then uh, DFS method of graph traversal. Okay, DFS method, depth first search, and algorithm also, like quick sort, merge sort, etc, etc. Okay, um, like pseudo solver. And one thing again I will tell you, every code of recursion we can write using stack as well. See, in our syllabus, DFS method is there, no? We can write also using stack. Okay, now I will explain you one famous program of recursion, GCD. Okay, I will explain you GCD, GCD using recursion, GCD using recursion. I will write code of GCD, int GCD int A. Two number we pass now, right? Yeah, int GCD int AB, and if this becomes 0, okay, if B becomes 0, then return A. Okay, and return GCD. I will call this function GCD again and again. Okay, uh, here B A percentile B. Okay, so as we know, this is code for GCD. I wrote correct. Yes, it is correct only, I guess. Okay, let's try find GCD of 48 and 18. Okay, what will happen? Again, I will explain using stack only. See, first GCD 48 18. It will go inside this, right? 48 18. Now here B is not 0. Then again it will call this. Now B is what? 18, and A percentile B is what? 12. So again it will call GCD 18 comma 12, right? Now GCD 18 comma 12. 18 is A and B is 12. So 12 will come here, and A percentile B is what? 6. Okay, huh, right, 6. GCD 12 comma 6. Now A is becomes 12 and B becomes 6. Okay, now again here B is not 0, so base case is still not reached. uh, GCD B is what? 6, and A percentile B is what? 12, and 12 percentile 6, so remainder is 0. So GCD of 6 0, GCD of 6 comma 0. Okay, now it will return what? It will return what? It will return what? 6. Okay, you can see here B becomes 0, base case is reached. Okay, once base case is reached, values are returned back step by step. Step by step. See, it returns 6. Now back 6, back 6, back 6. Okay, so GCD of 48 comma 18 is what? 6. Understood? Also, we can write Fibonacci series. Okay, I will write that also. Fibonacci series. Fibonacci series. Fibonacci series. Fibonacci series. How to find? Okay, int of Fibonacci int n. Mm, Fibonacci series one. Okay, 1 0. It looks like 0 0. Okay, if n is equal to 0, return 0. If n equal to 1, return 1. And I will call this Fibonacci repeatedly fib n minus 1 plus fib n minus 2. Okay, so if I call Fibonacci 4, what will happen? What will happen? Fibonacci 4 is what? Fibonacci 3 plus Fibonacci 2. And Fibonacci 3 is what? Fibonacci 2 and Fibonacci 1. And Fibonacci 1 is what? Fibonacci 1 and Fibonacci 0. Okay. This forms a tree structure. Each call creates two more. Okay. It becomes very slow for a large number. If you calculate for large number, it will become very slow. Um, okay. We use one technique also. What it was? Maybe a memojization, something we called. I forget name. So when to use recursion? When to use recursion? If when to use recursion? When to use? Like when the problem, when you have to solve any problem. Okay, and it is naturally recursive. Means you need to call that function repeatedly. Okay, like you want to find power also. Okay, for that also, when you need to call repeatedly. Okay, then use this example trees. And when you have to divide a problem into sub problems, then you use this. Okay, uh, okay, that's it. Or I will show you. I wrote that code, um, DFS, using stack. Okay, I wrote that code DFS using stack also. Where I wrote BFS. No, it is BFS. Where I wrote where I wrote. Okay, I will write here only. I'm not getting where I wrote. I will write here only. I'm not getting. Okay, that same DFS code. Okay, you see that lab manual. There it is written using recursion. I will show you. As I told you, every code we can write use of recursion. Use we can write also using a stack. See here. Uh, let's say agency matrix size we're giving uh, in PN, and from where you have to start, we need to pass right. And when sorry, first this start thing we need to push, right? And in visited we need to mark yes visited there. Okay, while stack is not empty. Okay, while stack is not empty. mm, mm, what what we will do in current, we will store pop. Okay, and after that we'll print this the current. Okay, now loop I will run. And keep in mind here we need to run loop from end less than equal to 0 I minus minus decrement by 1 if adjacency matrix sorry, if adjacency of what is this current means if it is present in the adjacency matrix and still not visited okay, I will write like this uh, and still not visited means we can write like this also, visited of I equal to 0. Okay, visited of I equal to 0, then push it in a stack and mark it visited. Okay. Mm, mm. So this is code. This is code for a DFS method of traversal. Okay. Thank you so much for watching the video.